Hello and welcome back to Thailand. It is early December 2024 and I and you, we're all back here in Thailand. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. My plan is now to stay in Thailand in the winter, in my condo here that I have been unable to sell because of the terrible market conditions post-COVID. And I will spend my summers in Barcelona. So I'm going to just bop back and forth. I got one of the new destination Thailand visas as a digital nomad. So I'm good to stay here for 5 years. And I'm going to just spend my time going back and forth. Now, that puts a bit of a glitch in my technical project development plans because I have a whole fully featured lab in Barcelona and I have an empty apartment here because I shipped all my stuff out. So I'm slowly working on repopulating this condo. I got myself a desk and a chair, a second monitor, a new ThinkPad, with the video connection on the HDMI, so I have the capability to write software and do circuit board development. I got a cabinet and I'm rebuilding my parts and tools supply over here. So I'm just getting started again. And the purpose of this video is to say I'm kicking off the new version of the EV fuel gauge project. I'm going to move to officially calling it version 0.2 because it's still in beta, obviously. And through the course of working on version 1 and all the issues I found, I now have a quite comprehensive to-do list of things I want to add to version 2 from the hardware. Let's go back up here. Hardware issues. Some of them I've already confirmed and those have a little check mark. The ones with a dash have yet to be implemented. There's some cosmetic issues with the board and labeling things, moving things around. And I have a testing procedure developed, which mostly all worked on version 1. Has got some things to, I'll redo the testing on version 0.2. The last thing I did was work a lot on the software with the configuration page to set all of your parameters to be able to use this in your vehicle and configure it to your specs so it works easily. And then I've got plans to get this actually fabricated through one of my 2 sponsors. The first one was PCBX. They're a little bit of smaller operation. And then, of course, JLC PCB. Now, once I get this version 0.2 board designed, I'm going to contact both companies. And my goal is to fly to their factory, do a factory tour, watch the board be manufactured, and then watch it go through the pick and place assembly line to the point where I have a fully populated board ready to power up and test. That's my goal for my time here in Thailand. I'm here until the beginning of March. Hopefully through December, I'll be able to get a new solid version 0.2 and I'll begin the communication with these companies and see how we go. Welcome back, folks. It's the first day of 2025. I don't know if it's going to be a good one or a bad one. That remains to be seen. But I have a story for you in terms of the circuit board that I'm working on trying to get to version 2. Now, as you might remember from the previous video, I was asking for help because I had a tremendous problem with Fusion 360 Electronics was giving me an error and it wasn't translating the schematic into the circuit board part of the system. And I'll click here, and there's the circuit board, and it's telling me my synchronization is deactivated. And so what I did was I went using the actually quite powerful versioning system of Fusion, I went back to the day that I committed version 0.1 and sent it off to manufacturing. I rolled my design all the way back, and then I was going to move forward again because the error went away. So I got back to a good point in the flow of the system. So I worked for a couple of hours. I started adding more and more parts in, and then Fusion crashed, right? And it asked me to type in what I was doing in order for their tech support to see. And then I fired up Fusion again, and you know what it did? It threw away all of those changes and put me back at the broken version number with the problems that exist in the board. Okay, that's not helpful. That's not what I asked it to do. When I went back to the previous version, I clicked and said, make this old version the new version, or whatever it is, make it the latest, right? And that was meant to be a springboard for me to then move forward past this nightmare that I've been living through. But Fusion crashed, and it took me all the way back to the bad version, and it threw away all the changes I made. So guess what? You're fired, said an orange-headed clown at one point. So I have to decide how to move forward. I had a couple of other ones that I was looking at, notably Circuit Maker and KiCad. Almost all the comments in that video said, I'm using KiCad, I'm using KiCad. And I know Damien McGuire is using it for his quite complex motor controller board layouts. So I gave both KiCad and Circuit Maker an evaluation. I asked all of the AIs to compare and contrast. They all came back and said, well, Circuit Maker is kind of derived from Altium, which is a tremendously powerful professional circuit board layout system. It's only at version 2. Now, I don't know that means much because of, coming from Altium's tremendously powerful history. It also has its own library management system where you can look up parts through something called Octopart. They say, we've got a bajillion parts in our inventory, right? And KiCad is at version 8 right now, and it's open source. And as much as I love open source, sometimes everything doesn't work right, given the state of my home assistant system, which I am constantly fighting, is a completely open source process. So you always have to take that with a grain of salt. There's no corporation behind it that's trying to, make it the best for the customers. But, Autodesk is this company, and it's garbage. So, I'll take open source over garbage all day long. So I did the tutorials for both KiCad and Circuit Maker. The Circuit Maker one here, the really funny thing is, it threw away everything I did in the tutorial because I just wanted to fire it up to show you the simple circuit that I made. It's just gone. And this is supposed to be a cloud-based solution where you have to click on save to server all the time. So that frightens me. KiCad, I ran this. I did a couple of tutorials. Here's the circuit board I laid out. Let's see, the schematic. Oops. The schematic is here. This isn't, a variation I was trying to do. But it all works. It all does the right thing. Although in terms of parts library management, they both suck. I cannot tell you how hard it is, unless you can find the perfect part you're looking for that's already built into the tools libraries. It is a nightmare to find one online with all three of the parts you need. You need the schematic symbol, you need the footprint of the layout for the board, which is here. This is a footprint for a switch. And then you need its 3D representation. And if I click Alt-3, I think, oh yeah, over here, it gives me a 3D view of the board. And if I come over and rotate it, you can see I have a resistor and an LED, but there's no physical representation of that switch built into that part in the library. So that's a big gaping lack of what I need it to do for me. Although, you know, having a 3D view of the board is nice. It kind of gives you a look of what it's going to turn out to be, but it's not critical in the design process. Now, one thing in KiCad's favor is you can import the entire DigiKey part library, or as many as they have, which is good. And then there's also a way for Snap EDA. You can do a Snap EDA search, but then you have to like save files on your local computer and then go into the symbol and footprint libraries and add them to your own local library, which, like I said, it's a pain. Anyway, so that's where we are now. I'm going to restart the layout of this board in KiCad, and I've got everything saved from the good version in Fusion. I have screen captures. I have the bill of materials spreadsheet. I've got everything I need to do to recreate this as fast as I can in KiCad. So after that giant rant, let's see how much progress I made, the problems I ran into along the way, and how long it took me. Okay, after I think about 20 hours, I'm almost back to where I was in Fusion with this board. The schematic is done, and the board components are laid out pretty well, and the 3D rendering was good. The only thing I really have left is to actually run all the traces on the board and connect all the pins up. Now, the learning curve was pretty painful, but there are a lot of KiCad resources out there. Just make sure they're talking about version 8, because a lot has changed through the years. So first, let's walk through the schematic. And because I had built the initial design in Fusion using mostly Snap EDA part definitions, it was straightforward, yet very tedious, to bring every part in and assign the symbol, footprint, and 3D image, because Snap EDA has a KiCad version 6 and above export format. I would love for KiCad to ditch its clumsy separate symbol, footprint, and 3D image systems and have one comprehensive part manager where you could handle all three aspects of each part together concurrently. But now that I know the existing process, I can power through it. Besides the normal schematic-y things, KiCad pays attention to the signal types of each pin on the device. As you can see, there are power input, bidirectional, and unconnected pins on the ESP32. This is meant to help you when you run the electrical rules checker, or ERC. But I found some of the pins are defined incorrectly, and the ERC gave an error. So I had to go in and correct a few pins on the imported parts. It will also complain if you don't have a power output defined. So I learned you have to attach a power symbol somewhere along the net where each power rail originates. And they look like this. Now that's different from assigning a net class directive like power to the nets that are going to be supplying power around the board. The power nets get highlighted in thick green lines, which is a good visual indicator of your power buses. But there are display bugs if you make changes to these nets. You also have to use the no connection tool right here to specifically mark non-connected pins, or you'll get another ERC error. All right, so let's walk around the board. The microcontroller section is identical from the previous version, except I added a second CAN channel, so I've defined a label for those pins. USB input has changed slightly. I added this diode protection chip on the data from the pin to the serial port chip, and I am now driving the LEDs from the internally generated 3.3 volt source, and I do not use this 3.3 volt source anywhere else on the board. This just stays internal. In the CAN bus section, I added another CAN bus channel in parallel, as I said before, and I also changed the CAN bus driver chips to take 3.3 volts instead of 5 like I was doing before. And that saved me from making a 3.3 to 5 volt boost circuit just to drive these two chips. So it was simpler just to change the part than to build a whole nother power supply section. Over here, the fuel gauge input is exactly the same. The pack voltage input section is exactly the same, but I fixed the bug where I put this resistor, instead of after the second one, I put it in between. So that has been corrected. The big change is with the power supply. Now, the tricky thing with this board is it can potentially get power from 3 different sources. It can get 12 volts from the car, which flows this way. It can get 5 volts from the USB connector, which flows that way. And it can get 3.3 volts through the JTAG debugging header. So what I needed to do is find a way to have all those power signals coexist and also drive the buck power supply to get us a clean 3.3 volts no matter what the input signal is. The simplest one is 3.3 volts from JTAG, goes pretty much straight through, but it goes through this MOSFET. The purpose of this MOSFET is to act like a block for reverse current or power coming from the 3.3 volt bus and back into the rest of that feed. It performs the same function as a diode would, but it has almost no voltage drop across it. You put a diode here, you're going to lose 0.7 of a volt, and I can't afford that. I don't want to go to 2.5 volts to drive my 3.3 volt bus. The 5 volt coming from the USB connector also has its own MOSFET, and the 12 volts coming from the vehicle has its own MOSFET, but it also has some test points, and it also has a Zener diode that will clamp the voltage coming in from the car at 12 volts to make sure there's no big voltage spike that comes in. And I also added 2 current limiting resistors in parallel to handle up to 0.5 watt of power coming through the 12 volt bus from the car. So that's pretty much it for the schematic. Now, to get to the circuit board, you press F8. Now, what you'll get is this dialog box that will tell you all the things that it thinks it needs to change to bring the circuit board up to the same as the schematic. There is a bug with some of the pins in the ESP32 where pins 46 to 50, they don't even exist, but it's still complaining. So I always just get rid of that. So what I've done is lay out each of those sections I showed you in the schematic and tried to lay out the parts in what I think will be the best possible flow. And hopefully this will turn out as I start laying out the traces. There obviously will be changes, but they should be minor. One of the cool things is you can assign a color to your neck class. So I made my power rail yellow. So every yellow thing you see here is 3.3 volts or 12 volts or 5 volts. And that helps me understand where I need to make really good flow for these signals around the board. Now, the problem can be that I've found there is a dynamically always running design rule checker. You can run the design rule checker and it will tell you if it thinks anything is wrong, and even to the point where the lettering is overlaying a pad. And I've got it down to only unconnected things and some tests that I ignored. So that's good. A big problem I found is that since I defined the wire size for the 3.3 volt bus as 3/4 of a millimeter, the dynamic on running all the time design rule checker literally will not let me connect the bypass capacitor to the power pin on the chip. You see how this is going? It won't let me connect to the pin because the pin, because it's defined as a power pin, has this giant protective bubble around it. And I literally can't make that connection no matter what I do. So I'm going to have to do stupid things in order to make these power buses connect up. All right, now let's take a quick look at the 3D view of the board as it stands, and you get that by hitting Alt-3, and you get your board with all of your 3D packages laid out. Now, if there's a footprint missing, you have to go back to the circuit board layout, go into its properties, into its footprint properties, and find the file connected with the 3D image. And you have to do it every part by part, even though these are identical and these are identical, and there are 17 of these test points. I had to do them all by hand because there's a bug where the system will not keep the 3D image associated with a particular footprint for every part of the board. Anyway, so this is pretty much what it's going to look like, and I'm pretty happy with that. I will be able to change the dimensions of the board as things go along. But I'm at a really good place right now, and now I get to start laying out the traces between all of the parts. I want to give a quick shout out to my new sponsor, PCBX. It's a circuit board and board assembly company, which turns out is right on the mark for me. I saw a post for their Facebook page and was interested in their capabilities, so I joined the group. PCBX isn't as well known as some of the other circuit board companies, but they've got the facilities to compete with up to 8-layer boards, 2-sided SMT assembly, and over 200,000 parts in their catalog. They also offer their own design tool, but can accept native files from KiCad, Altium and Eagle, and of course, standard Gerber files. The interesting thing for me is that they happily support people like me who only need prototypes and low volume orders. Their circuit board prices are about the same or a little cheaper than the others, but they say their board assembly has better quality at a lower price. As a new customer, you have immediate access to great prices and big discount coupons for boards and assembly services. To top off the partnership, I hope to visit their Shanghai factory this winter and make a great video so everybody can see their capabilities. So be sure to check them out the next time you're uploading a board design. Okay, welcome back to the board. We are finished. The component layout pretty much stayed the same as I thought it would. I had to move some things around for spacing. It looks pretty cluttered, but let me turn off the back. And you can see I tried to use really thick traces for almost all of the traces on the board, mostly because there's a lot of power flowing around the board, and the thin ones are the signal level things, the output to drive the fuel gauge, the in and out transmit and receive of the CAN bus, the in and out from the USB-C port, and the debugging header. Everything else I tried to make as beefy as possible. And I also, if I flip back to here and turn the front off, you can see I poured ground planes. There's an independent ground plane for the high voltage side, separated by a gap, and also the opto isolator has a physical separation. These are the high voltage pins, these are the low voltage pins, and then there's a ground plane for the low voltage side with a keep away for the ESP32 antenna. I did have to go on the back side to run some of the signal traces and a couple of big power traces, but it doesn't pollute the design too much. Now, for the fun stuff, let's have a look and see how this looks in 3D. So here we are. The board looks pretty good. The spacing is nice. All of the components are well labeled. And you can see there's a lot of status LEDs and a lot of test points. So in the power supply section, this is both the test point for 12 volts and the LED that lights up when 12 volts is coming in. The test point and LED for USB power here. The test point and LED for JTAG power. And then the output power of 3.3 volts to the rest of the board through this buck converter highly efficient power supply. Everything else is good. We've got mounting holes, and yeah, I'm pretty happy with everything. I got my logo on there. That was not easy. Oh man. I got a description of the board. We've got all the connectors labeled, and there's a couple of Easter eggs here. This is something that SpaceX puts on all of their circuit boards, and this is a little thing if Sandy Munro ever sees one of my boards. The Tesla people put a little message for Sandy there, so I figured I'd join the club. Now, going back to the circuit board layout, I wanted to stress one thing. Now, I don't want to necessarily mess up my design, but if I was working on this chip right here, say I wanted to move it down 0.5 millimeter to make something better for the spacing, I would click the chip and I would drag it down. I would expect that the traces that are connected to those pins would rubber band themselves and maintain connections to the chip and rejigger themselves to follow wherever the chip got dragged, but they don't. So let's give that a try here. If I do this, look at that. Nothing. So this is a major, major shortcoming of KiCad, that it doesn't rubber band the traces to the pins. It's almost like there's no logical connection between this pin, the trace, and this pin. It's just graphics. It's just drawing lines. It's drawing dumb lines with no knowledge behind it. Now, as I said before, I understand this is an open source volunteer project, but after version 8, I would hope that it would start to pick up some of the more sophisticated things that you would expect in a circuit board layout system, because overall I'm pretty happy with it. I do hate the component management, and I don't like that it doesn't rubber band pins, but the design is done, and I'm ready to ship it off to my friends in the Chinese circuit board companies. I've sent 4 companies an email with my proposal that I fly to their factory. I do a factory tour. I make a video of my boards being made and assembled. In exchange, they give me something. Worst case, they give me access to the factory, and you know, I can document all this for you. Next worst case, they chip in on some of the expenses. Now, I have all of the parts to make 5 boards, so I can bring those along with me. But a plane ticket and a hotel room would be nice. Hey, if you're not going to ask, you're not going to get it. So I'm going to wrap it up here, and I will let you know how the manufacturing part turns out. The next video may be me wearing a bunny suit in a circuit board factory in China. Cross your fingers. We'll see you soon. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig for their ongoing support. I see that a whopping 96% of my viewers are not subscribers. So please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks and take care, and I'll see you in the next video.